Welcome you all to this continuation of the second mock paper. Due to power cut, I was not able to do the full paper during my first lecture. So I am continuing as a part 2 lecture. So the question number is 14th question. I didn't, the previous lecture I did till question number 13. Now I'm continuing with my lecture, question number 14. The sinusoidal wave is propagating in negative x direction in a stretched string. The particle of the string at x is equal to 0 is found to be mean position and it's moving in positive x direction. Since it is moving in positive x direction, that should be sinusoidal. It's a sinusoidal wave and it should be sine, and it is at t is equal to 1 second. If the same wave, if that point is the origin, that particle is at the origin and t is equal to 0 second, the wave equation would have been in this form. Y is equal to, if it would have been at origin, but this is at 2 meter and at 1 second. At origin x comma, this is y at x comma, x is equal to 0, 0 comma 0. This is x comma t. X comma t is 0 comma 0. The equation y will be equal to a sine omega t plus kx. So plus kx. The plus sign is because it is moving in negative x direction. But this particular wave, the particle is at x is equal to 2 meter. And it is after 2 seconds. Since it is 2 meter along positive x direction and 1 second after this this time, so I am shifting the time and the x axis. The x part I am shifting that one. So y is equal to, it will become a into sine omega times t minus 1. 1 second I am shifting. Since this wave happens 1 second afterwards, so I am shifting it 1 second backwards. Plus k, because 1 second before the wave would have been at the origin. K times x minus 2. Yeah, I am shifting that reference axis to this point. So this is the equation. Y is equal to a sine, a is 0.1. Sine omega is given to be 2 pi, I think. Yeah, angular frequency is 2 pi. So 2 pi times t minus 1 plus k is equal to 2 pi by lambda. K is equal to 2 pi by lambda. 2 pi by lambda. Lambda, the wavelength is given to be pi by 2. So this will be 4. So 4 times x minus 2. That will be the answer for this. So this answer is 2 pi t minus 1 into 4 times x minus 2. So this should be the answer. So next question, 15th question is, in an experiment, a small steel ball falls through a liquid at a constant speed, 10 centimeter per second. If the steel ball is pulled upward with a force equal to twice the effective weight, how fast will it move upward? The first part of the sentence, it is moving downward with a constant speed. That speed is called as terminal velocity. That speed is called as terminal velocity. So I will draw the diagram for the first part of the question. So the weight of the object W will be downward and upthrust will be U will be upward. And the friction force, since it is moving with the velocity V downward, the terminal velocity V is downward, the friction force, that is the viscous force, will be upward. Viscous force is kind of a friction force in liquid. That is the viscous force F. So since it is moving with a constant velocity, that is the terminal velocity, the net force is 0. So you can write an equation here, F plus U is equal to W. The second part of the question is that if the steel ball is pulled upward with a force equal to twice the effective weight. Here the effective weight is W minus U. Here the effective weight is, the weight is W, but the effective weight inside the liquid is W minus U. Effective weight is W minus U. So now, according to the new situation, this W is there already. So this one is U, and you are pulling it upward with 2 times the effective weight, W minus U. And but the viscous force will be downward now. It will be downward in this case. Now here you can write for equilibrium, and it is moving up with the same storm velocity v. Here in equilibrium, so here F should be equal to the viscous force, which is 6 pi eta AV. Here F is equal to W minus U. So let us find what is F here. So this is 2 times W minus U plus U minus W minus F is equal to 0. 2W minus W will be W, minus 2U plus U is minus U, equal to F. So F here is also equal to, here also F is equal to W minus U. Here also F is equal to W minus U. Here also F is equal to W minus U. So F is equal to 6 pi eta AV. Maybe if this is F dash, here the viscous force is F dash, means this F dash is equal to F here. F dash is equal to F. That means that both the velocities, speed, the terminal velocity should be equal. So it should be 10 centimeter per second only, because this is 10 centimeter per second. So this is upward 10 centimeter per second. So next question, 16th question. A ball of mass 60 gram is thrown up with an angle of 60 degree to the horizontal at a speed of 10 meter per second. So if you are going to throw a ball with an angle of 60 degree, say with a speed u, at the highest point, it goes and falls down like this. At the highest point, its velocity is going to be u cos theta. The vertical velocity will become 0 at the highest point. The only velocity is u cos theta. And the momentum will be m into u cos theta. The momentum will be m into u cos theta. In this problem, they are asking you angular momentum of the ball at the highest point of the trajectory with respect to the point of projection. From this point, they are asking you what is the angular momentum. So here, the momentum line is this. This is the momentum line. If you multiply this by m, this becomes the momentum vector. And always you find the angular momentum as the angular momentum is nothing but the momentum into the perpendicular distance. The perpendicular distance here is this one. This is the perpendicular distance, which is h max. So the angular momentum L is equal to, at the highest point with respect to this point of projection, is momentum vector is mu cos theta into h max. So in a projectile motion, h max is equal to u squared sin squared theta by 2g. So that will become m u cube cos theta into sin squared theta by 2g. Theta is given, m is given, u is given, m is going to be 160 gram. Converted into kilogram, it will become 0.16 kilogram. And u is going to be 10 meter per second. And theta is going to be 60 degrees. Substitute that one. G, that asking you to take it as 10 meter per second square. You can substitute that one and find the answer. So I'll leave the calculation for you. I'm doing the next question. Question number 17. A block of mass m is attached to a massless spring force K. The block is placed over a rough inclined surface. This is placed over a rough inclined surface whose coefficient of friction is 3 by 4. Coefficient of friction in this surface is 3 by 4. The block M is initially at rest. The block capital M is released from rest. This is released from rest. In spring problem, there is a difference between release and dropping it slowly. released, if you are going to drop, if this is the natural length of the string, and if you are going to hold the string, and it is at the natural length, if you are going to slowly leave it, then it will, when it comes to the, when it comes to rest, it will be kx will be equal to mg. But in this case, if this is the natural length of the spring, and if you are going to, you are holding it and you suddenly leave it, if you are releasing it, here you are not, you are just releasing it very slowly. You are not taking out your hand. You just hold this block and slowly you release it, and it will come to rest at a position where kx is equal to mg. But when you release it, it falls abruptly. In that case, you have to conserve energy here. So in that case, half kx squared is equal to, that is the gain in elastic potential energy of the spring, is equal to loss in gravitational potential energy, that is mgh. In this case, it is mgx. So in this case, kx will be equal to 2mg. Your x and x gets scored out. Kx will be equal to 2mg. I will use capital M. For this case, it is capital M here. You are releasing this one. So in this case, capital M, for this case of question, capital kx will be equal to 2 capital M. This is the first equation because this is released. For this, I will draw a free body diagram for this. This is the one. Kx will be in this direction, and the mg will be in this direction. Mg sin theta actually. This will be mg sin theta. Mg sin theta, and friction force mu mg cos theta. Friction force along the incline will always be mu mg cos theta. That's the maximum friction force. Mu mg cos theta will also be in this direction. So you can write the equilibrium equation here. Kx is equal to mg sin theta plus mg sin theta plus mu mg cos theta. So Kx is equal to 2mg. So 2 capital Mg is equal to, this is small m. So you can cancel G. When you cancel G here, I'll get this is G sin theta. Theta is, here theta is going to be 37 degree. Sin 37 is 3 by 5. So I'm cancelling G. So 3 by 5 m. This will become 3 by 5 m. Plus this mu is going to be 3 by 4. And m is getting cancelled. Sorry, G is getting cancelled. Cos 37 is 4 by 5. This will become 4 by 5 m. So this 4 and 4 gets cancelled. So this is 3 by 5 m plus 3 by 5 m, that is 6 by 5 m. So 2m is equal to 6 by 5 m. So m should be equal to 3 by 5 m. So this should be the answer. That should be the answer. So the next question is, a charged particle of mass m and having a charge q is placed in an electric field E which varies as E is equal to E naught sin omega t. What is the amplitude of the simple harmonic motion executed? Now we will see the what is the force acting, that is the restoring force acting on the charge q. So F is equal to, since the direction of the electric field this keeps on changing, it depends on sin omega t, which could be positive or negative. So it keeps on changing like this. So in that case, the force acting, the restoring force acting on the charge will be F is equal to Q E naught sin omega t. Q E, E is E naught sin omega t. Q E naught sin omega t. I can add a negative sign here because it's a restoring force. So acceleration will be equal to minus Q E naught by m. Acceleration is equal to force by mass. For small angles, I will take it's a theta. So if I compare this one with, this is going to be omega. This is going to be omega square. So omega square is equal to Q naught, Q E naught divided by M. We know that maximum acceleration is equal to A omega square. A omega square. So A omega square is, and maximum acceleration is also going to be equal to Q E naught by M. This is going to be the maximum acceleration. This is equal to maximum acceleration Q E naught by M. A omega squared is equal to, because sin theta is maximum value of sin theta is 1. So what will be A is equal to? A is equal to Q E naught by M omega square. Q E naught by M omega square. So this should be the right answer. So the next question is, the 19th question is, in a photoelectric experiment with a light of wavelength lambda, the fastest electron is V. So half mv squared is equal to hc by lambda minus phi. Phi is the work function. If the exciting wavelength is changed to 3 lambda by 4, so half m v dash squared is equal to h3 by 3 lambda by 4. 3 lambda by 4 minus 5. So from these two equations, you can't find the value of v dash, but you can easily understand that v dash is going to be greater than v here. You can't find, you cannot deduce the value of v dash without phi. With phi only you will be able to deduce the v dash value, because even if you are going to substitute instead of h3 by lambda, if you are going to substitute this one also, then also you will get phi here. You will get that phi value. So you cannot deduce exactly value of v dash in this case. If you don't know what is phi, you can find the value of v dash in terms of phi only. So, but it is easily understandable that v dash should be greater than v here. V dash should be greater than v. So this cannot be the answer. This cannot be the answer. This cannot be the answer. So this should be the answer in this case. So the next question is, the 20th question is, the thin convex lens of focal length 10 centimeter and refractive index 1.5 is vertically cut. Whenever you cut this is a theory which you would have learned already. Whenever you cut it into two halves like this, then the if this is f means this E shaft will become 2f. This will become 2f. So this is something which you studied in your boards also. This will become 2f. So here, so this will become 2f. 2f means here f is equal to 10 centimeter. This is 10 centimeter means this is focal length is 20. This focal length is also 20. You have another liquid lens in between. That is a concave lens. So the focal length of the liquid lens, you have to find the focal length of the liquid lens. Focal length of the liquid lens. Of the liquid lenses. You have to find the focal length of the liquid lens. In that case, the focal length of the liquid lens is going to be 1 by f liquid lens is equal to, the refractive index of the liquid is going to be 3. So it is mu minus 1. So 3 minus 1 into 2 by r. Into minus 2 by r. It is a concave lens. So it will be minus 2 by r. You don't know with this r, but you can find r from this lens. You know 1 by f is equal to, for this lens, 1 by f is equal to, mu is 1.5. 1.5 minus 1. For this lens, refractive index is 1.5. Minus 1 into 2 by r. It is 2 by R because this is a EQ convex lens and this is a EQ concave lens. This liquid lens is a EQ concave lens. So this is 2 by R. So this is going to be, this one you know, this is going to be 10. And this 1.5 minus 1 is 0.5 into 2 is 1. So R is equal to 10 from here. From here you get R is equal to 10. You can substitute R is equal to 10 here. So that will become 1 by FL is equal to, if you substitute 10 here, this is going to be 3 minus 1 is 2 minus 4 by 10, which is minus 2 by 5. Minus 2 by 5. Yeah, 2 by 5. Yeah, 2, this 2, 10 cancels, minus 2 by 5. Now there are 3 lenses here. This is the first lens. So 1 by F effective focal length is, you know, 1 by F1 plus 1 by F2 plus 1 by F3. The first lens 1 by F1 is 1 by 20. 1 by 10 actually. 1 by 20, correct. 1 by 20. The focal length of this lens is 1 by 20 plus. The second one is the concave lens, which we have found to be minus 2 by 5. The third one is also plus 1 by 20. So this is going to be, this you can write it as 8 by 20. So minus 8 minus 6 by 20 it is going to become. This minus 6 divided by 20. So focal length is 10 by 3, minus 10 by 3. So this should be the right answer. Minus 10 by 3 should be the right answer. So the next one is the activity. This is the numerical type questions. The activity of a radioactive substance drops to 1 by 32 of its initial value in 7.2 hours. The activity drops to this one. If this value is like 32, which is 2 power 5, easily you can say this happens after 2 power 5. 1 by 32 is 2 power 5. 1 by 32 is 2 power 5. 1 by 32 is 1 by 2 power 5, which means this implies that 5 half-lives. 5 half-lives there. 1 half-life is T means this is 5 half-lives. Here in this problem it is going to be 7.5. So T should be equal to 1.25. 7.5 divided by 5. 7.5 divided by 5 is 1.5. T is equal to 1.5 hours. So this is going to be 1.5 hours. And for this one, 6 resistors of 10 ohm each are connected in shown. The equivalent resistance between point X and Y is between this one. Here, this and this, if you see this one, this is a Kirchhoff network. This is a Wheatstone network, sir. This is a Wheatstone network where you can cancel this part. The current will not flow into this one. So these two and these two becomes parallel now. And this also becomes parallel. This is 10 is in parallel. This is 10 and 10, 20 is parallel. This 10 and 10 also will become parallel because this is not there. So this also will become parallel. So the effective resistance is going to be 1 by 10 plus 1 by 20 plus 1 by 20 is equal to 1 by R effective. So that this is 2 by 20, which is this is 1 by 10. 1 by 10 plus 1 by 10 is 2 by 10. So this implies R effective is 5. R effective is 5 ohms. So the answer is 5 ohms here. Next one. The electric potential V given as a function of X. V is given like this. Find the value of the electric field at X is equal to 1 meter. So we know that the electric field E is equal to minus dV by dx. Minus dV by dx. These are all very easy problems. So which is equal to minus dV by dx is, you differentiate this one, you get 10x plus 10. 10x plus 10. In this problem, they are asking you at x is equal to 1. At x is equal to 1, if you substitute 1 here, this will become 10 plus 10 minus 20. So the electric field here is going to be minus 20. Next question. The 3 moles of ideal monoatomic gas perform a cycle as shown in the figure. The gas temperatures at different T1, they are given what is the temperature here, 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 all the 4 temperatures are given. Work done by the gas. Here, if you look carefully, this is a pressure and temperature graph. In a pressure and temperature graph, this is pressure and temperature. If you have a straight line like this, then the slope of pressure and temperature is constant, which means volume is constant, because we know that PV is directly proportional to T. So if P by T is directly proportional to 1 by V. If P by T is nothing but the slope of PT graph. If the slope of PT graph is constant, then 1 by V, that is V, is also constant. If P by T is constant, then V is constant. Which means that is the isochoric process. This is the isochoric process. In isochoric process, the work done is 0. So work done from these two lines, you can see that P by V is constant. So work done from 1 to 3, work done from 1 to 3 plus work done from 2 to 3 plus work done from 3 to 4 plus work done from 4 to 1. Here, work done from 1 to 3 and work done from 4 to 1 are, 3 to 4. 3 to 4 are isochoric process. So this is 0 and this is 0. Work done from 2 to 3 is NR. N is the number of moles into R is the gas constant into T3 minus T1. T3 minus T2, plus work done from 4 to 1 is NR. So because it is the pressure is constant here. In this case and in this case the pressure is constant. Work done when the pressure is constant. Pressure is constant means this is isobaric process. In isobaric process, the work done formula is this one. NR into T1 minus T4. T1 minus T4. So this is 0. So this is N. N is 3 moles is given. It's given initially itself given 3 moles. So 3R times T3 minus T2. T3 is 1600. T2 is 400. So this becomes 1200. This is also NR, 3R plus T1 minus T4. T1 minus T4. T1 200 minus T4 is 800. This gives you minus 600. So this will become minus actually. Minus 600. So this will give you 2600. 600 into 3 is 1800 R. 1800 R. You multiply this R is equal to 8.33 and you will get the answer. So 1800 into 8.33 joules. So that is the answer for this one. 1800 into 8.33 by 1000. They are asking in kilojoules. Here you are finding in joules. Divide by 1000, you get it in kilojoules. So 1.8 into 8.33. 8.33 into 1.8. 0.33 is 1 by 3 approximately. So this is 8 1 by 3, which is 25 by 3. 25 by 3 into 1.8. This one is 0.6. So this is 15. 15 kilojoules. The answer for this one is 15 kilojoules. So 25. A body is executing a simple harmonic motion at a displacement x from the mean position. Its potential energy is 2 joules. Potential energy formula is half kx squared. So half, so 2 joules. E1 is equal to half k x squared is equal to 2 joules. E2 is equal to half k y squared. That is the second part of the question. Is 8 joules. So they are asking you potential energy at the displacement x plus y. So E is equal to half k x plus y the whole square. Instead of x plus y, instead of x you can write, this is E1, no, this is 2E1 by k. Instead of x you can write root of 2E1 by k, half k into root of 2E1 by k plus whole thing root of 2E2 by k, the whole square. Since this is squared, you can take this 2 by k common outside. When you take 2 by k common outside, this gets cancelled. So this will become root of E1 plus root of E2 the whole square. So root of E1 is root 2 plus root 8. The whole square. You can easily calculate that one. So a plus b the whole square you can use. Root 2 the whole square is 2 plus 8 plus 2 root E1 E2. That is root 16. Root 16 is 4, 4 2s are 8, 8 plus 8, 16, 17, 18. So the answer should be 18 joules. 18 joules. So this is the end of this paper. Thank you all for your support. Keep watching out my videos. So see you all in the next video.